Swayam Prabha. Digital India. Educated India.
Today we will discuss geotechnical engineering, which will be our 7th lecture in this module. So far you have introduced this term geotechnical engineering quite a number of occasions in this course, I believe, isn't it? And as you understood that this geotechnical engineering is the one that deals with what lies beneath, what is there below the structures. That can be anything. That can be a bridge, that can be a building, that can be a water treatment plant which you have gone through, that can be a dam in hydraulic engineering for anything. So, basically geotechnical engineering comes as a part and parcel of all other branches of civil engineering, because everything has to stand something on it. So, that is where the geotechnical engineering's importance comes into the picture. Now, what is geotechnical engineering? Geotechnical engineering is the branch of civil engineering concerned with engineering behavior of earth materials. That is the key word here. So, what is available naturally in ground? What forms the top part of the earth on top of the crust? We are generally worried about that, because that is where the load of the structure will be transmitted, because this building, let us say, it is standing on ground, right. So, who is taking the load? The load is going to the below the foundation and to the finally to the mother earth. So, we kind of worried about the behavior of this earth, natural earth material, which is finally kind of taking the load from the structures. So, geotechnical engineer uses the principles of soil and rock mechanics to investigate the subsurface conditions and materials. So, what is their role? Number 1, determination of physical and chemical properties of geomaterials, very important. So, what are the properties? The soil there, what are the properties? How to characterize a soil physically or mechanically? In fact, it can have a same physical property, but completely different chemical type of compositions. Design of foundation, of course, each of the we will discuss this in the subsequent slides also, that the foundation, that means each of the structure will have a certain structural material below ground which is not been visible from the outside, that is called foundation of the building. Now, how to design that foundation for different type of soil, different type of building, different type of structures as such. Design of excavation support system, you must have seen lot of excavations in the urban areas. Those who are from Chennai or any kind of metropolitan cities, you will see that we are doing lot of excavations and tunnelings for the metro railways, all the cities, major and semi-major cities. So, for all these metro railways, whenever it goes down below the roads or any kind of land, you need to do a lot of excavation. I mean, you need to dig up the soil. Now, how to stand? Do you think soil is a very soft material as such compared to concrete or steel? So, if you dig up say 10 meter or 15 meter, definitely both sides of the soil will try to collapse, right. You cannot simply just dig up. Of course, you can dig up to certain level, beyond that the thing will collapse, the cave will collapse. So, how to support that? That is where the excavation and support systems comes into the picture. So, when you do the excavation, there should be an engineering behind it. How to resist the collapsing of the soil, what are the depth is required, or how much depth you can do safely without any support system. All this thing comes into the purview of the geotechnical engineers. Next one, number 3 is the number 4 is the evaluate stability of natural and man-made slope. Many of you have seen, I mean, when for your traveling to the any kind of hilly side, right, hilly terrains. Hilly terrains, how we do the kind of extend our road networks, it is like that, it is like a meandering path, it will go like this, right. It is a hairpin bends are there, some part you will see that the road are very narrow, some part suddenly it is a bit wider, and then it's a very challenging, because there is a gentle slope, at the same time it's like a helical type of network. Now, unless the slope, the surface of the hill is stable, how you are going to construct this road, isn't it? See, if there is a continuous fall of rocks occurring, then nobody will be able to drive that road, right? So, basically geotechnical engineers' responsibility is to ensure that the slope of the hill, which now naturally there, so if it is naturally it is not safe, then you have to do something, you have to cut the slope, you have to kind of do some kind of engineering, so that the slopes are stable in nature, it is not falling to the road. Same thing applies for, let us say, landslide happens. See, landslide, there are various reasons for landslide, but as such, like earthquakes is a natural phenomena, you have to design your road or design your slope so that it can kind of resist, even if there is a chances of external agents, external reason for the landslide, the slope should be able to hold it up. But still there may be some landslides, right? We are seeing every time some rain happens or earthquake happens in hills, there will be a landslide, there will be road blocks, all kind of stuff. So, the geotechnical engineers' responsibility also holds on there, that how to kind of prevent continuous landslide to happen or too frequent landslide to happen. And even if there is a certain region which is a landslide prone, what are the precautionary measures you have to take? How to stabilize that slope? That is all this thing comes into the picture. Whenever you visit a hill, you please, now onwards you just please make a note of it. You will see many places the slope, when you just watch out of windows of your car or of your bus, you will say that some kind of treatment is done. I mean, it is not natural, there is not much tree there, and that particular section may be tied with some cables, there are certain maybe big bulk of the stones kind of mounted, or can be just a reinforced concrete. The simple reason behind that is we are just doing something so that the slope will not collapse to the road. Finally, the very important thing, the fifth one, the field investigation and monitoring the site conditions. So, all good things said and done, once you have come out of the site, general tendency is to think that okay, this will be fine. Like we buy something, so let us say we buy a laptop, right? Initially first few days we will be very careful, do not touch anything, so that everything is nice, we do update regularly, all those things. After 1-2 years what will happen? We take it for granted, right? We just simply use it without thinking its health. So, same thing stands for all the geotechnical structures, even more actually. So, we do something, all we protected kind of slope, we have designed foundation with a marvelous accuracy and engineering sense, but unless you monitor continuously the performance, then you may end up losing the design life. So, let us say a particular tunnel, a design for a design life of say 100 years, unless you continuously monitor that is there any water seepage going on inside, is there some part of the shortcreting, that means the surface of the tunnel is getting deteriorated. So, all this thing will tell you that what is the health, what is the condition, it is just like our health, same thing, what is the condition of the tunnels, or same thing applies for the bridge foundations or regular foundation. So, there are certain level of electronics involved here, because you have to continuously monitor with a certain type of sensors. So, you install those sensors and then you get the data back in your office with nowadays data is not a problem. So, you continuously see that okay, every 15 days let us say you just take a stock, how is the performance is going on. So, there are several types of sensors are available, which is also purview of geotechnical engineers to maintain the power, battery, everything, how to enhance the battery life of those kind of sensors, everything comes under the for certain areas of geotechnical engineering. Now, everybody knows this, right? Taj Mahal, right? It is one of the wonders of the world, but the problem is superstructure we all see, but what is there at the bottom? We have almost no clue until very several years. There are a lot of speculations, there are a lot of old scriptures are there, that what is there, how the foundation of the Taj Mahal, but finally what happened is our part of our structural group, Dr. Arun Menon, he has given you lecture on architecture and the heritage structure, There are Archaeological Survey of India, part of the side of Taj Mahal, kind of excavated, and what we saw here is very interesting. So this is the excavation we did, and this is the base of the structure, and this is what the foundation is this kind of well type of shape. Have you seen this? This is a well. So this is called a special type of foundation material element. It's called well foundation. It's just like your regular wells. So it's below the Taj Mahal. There was a scripture. It's not that we are completely surprised to see this. There are earlier old scriptures which says that there is well foundation used in Taj Mahal below that. So it's a very interesting thing. So these are the wells. There are some hundreds of wells are there below this structure, and this inside these wells, it's filled up with any kind of debris. Whatever debris that time they have available nearby, they just dumped it. Some wood piece, some tree trunks, all kind of stuff. They dumped it, do some little bit of compaction, whatever possible in those days, and they build the structure. And it was so nicely standing. So there was no problem at all in the foundation or any kind of tilting of the superstructure. So these are the very interesting fact. Without knowing foundation engineering itself, people are doing that kind of wonders, because these are coming from the practical sense. So what does it say? So Richard Handy says a very interesting comment, that virtually every structure is supported by soil or rock, those that are not either fly, float or fall over. It's very, very important. It's a very cynical second line, but this actually tells the entire story, that everything there is a foundation. It's without foundation it will never be able to stand. Okay? So in his practice, civil engineer has many diverse and important encounters with soils. So where as a civil engineer will just go through the different situation. We have just started with the introduction part. Now you will see that where exactly, what are the different challenges a geotechnical engineer will have. I mean, as a past of civil engineer, you will be handling. First one, of course, as I said, there is a foundation. Now there are foundations, means there are two types of foundations generally available. One is called shallow foundation. Shallow foundation, so this is your superstructure, very obvious. And at shallower depth, you have this slab. In plan, you will be something like this. So this slab is nothing but your foundation. So this one we call it shallow foundation. There are different types of shallow foundations available: isolated footings, combined footings, raft, different type. But one of the common feature of them is this depth of the foundation is kind of not in a very large value. So usually the criteria is the depth of foundation should be less than the width of the foundation. So it's that's the thumb rule we specify for shallow foundation. But you can understand that shallow foundation is a one which is rest or which will transfer the load of the superstructure at shallower depth. That is the idea. So depth of the foundation. So this is the ground here, and this is the foundation. So it's a very nominal depth compared to, you see the size of the foundation. Size of the foundation is quite big, right? The dimension is quite large. Now this is fine. This type of foundation is, I mean, perfect, and in fact I would always prefer this because the cost is less, construction and problem is less. But there is a but here. The but is the soil surrounding this should be good enough to take that load, isn't it? See, ultimately what is the purpose of foundation? Foundation is transferring the load. Whatever load coming from the superstructure via this structural element, it is transferring to the adjacent soil. Now if adjacent soil is very weak, means what? They will not able to take. So what will happen? If you put a brick in a, let's say, in a kind of a very muddy type of environment, what will happen? That guy will settle, isn't it? Same thing will happen. Because why it is settling? Because you are giving a foundation to a soil which is not capable of taking it. So what they will do is they will say, no, 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 I can't take, you try below. So entire structure will go down, sink below. That is what we are. Do you think that a building or a bridge which is settling, you will be very comfortable to stay there? No, right? So, one of the major serviceability requirement for any structure is the settlement has to be in a certain nominal zone. There are codes for it, that how much settlement is allowed and all this thing, but generally you do not feel comfortable if something is settling every day, is not it? Now, in those kind of situation, what you have to do? The foundation, by sinking itself, gave you a hint that there is a soil. It is not that the soil is bad. There is a soil which is slightly below than that area, which can take that load. So, that is why I am sinking up to certain level. So, what you have to do is simply you have to transfer the load to a deeper depth. So, that is where the term deep foundation comes into the picture. So, now there is this is a structure, maybe heavily loaded structure, then there is a piles. These members are like your columns. It will transfer the load to a much better soil which is having very high density. Maybe the rock itself can transfer the load. It is very similar to your stools. Piles are very similar to your stools which we sit. So, you sit on top of the some kind of platform, right? If there is no leg, what will happen? You and the platform both will collapse. So, there are 4 legs to the platform. So, these legs, what they are doing? Your load which is resting on that platform on top, getting transferred through those 4 legs to a ground which can take that load, is not it? So, those 4 legs in geotechnical engineering is just deep foundations or piles. There are many types of deep foundations. One of the most common one is piles. So, wherever the soil is good at much lower depth, to reduce the settlement of the structure, we generally transfer the load to that competent soil layer. So, this is a key word, competent soil layer. That means the layer is competent enough to take the load of the superstructure. So, that is what deep foundation will be doing. Now, this is the first job, the design of foundations, whether it is shallow, whether it is deep, how to design, what should be the depth, what will be the size of piles. Like you have stools, like 4 leg stool, you can sit, it is safe, but it's an elephant is sitting means it may break, right. So, you have to design a stool, design those legs based on the loading. So, that is where the size and shape and the depth of the piles, everything will be determined by the geotechnical engineer. Now, very important, this is in fact you no need to know anything. The civil engineer uses soil as a construction material. How many years we are doing this, I do not know. Ancient itself we have the mud houses, is not it? This side is the mud houses, very standard, everywhere now still there in the villages, is not it? And these are technically it's simple, but it is kind of sustainable, we are seeing that. Now, the more importantly, the soil can be used as the embankment material. Like you see, this is constructed by the soil only. So, this side the water. So, what is the purpose of this? This may be the flowing river. So, this embankment what will do is, even at the raised height of the water, this embankment will protect, so that the water will not flood in this agricultural field. Well, there may be cases that the rise of water beyond the depth of, the height of the embankment, that time it will flow, but that is extreme situation. But in general, under what we do is, under high flood situation, what should be the height of the water? We keep some 1.5 to 2 meter on top of that, and we create the embankment based on the soil. Now, there will be of course certain properties of the soil that will be evaluated to choose the material. Not all the soil, whatever soil available locally you can use it. There are certain characteristics of the soil is required to create, to be selected as a good embankment material. But this is where another major infrastructure, day-to-day life of the people will be kind of involved, isn't it? Unless this is a, everywhere we see this, we call it earthen embankments. Now, as I said, the excavation and support system, you see this is the excavation, what I am saying. This is a typical metro rail or similar type of excavation site, and you see the depth of the excavation is, ground is somewhere here actually. The depth of the excavation is maybe sometimes is a 3-story building. So, 3-story building means it can be about 10 meter height minimum. So, 10 meter to 12 meter to 15 meter, 20 meter, 30 meter excavation also there. If you have a very deep basement or certain activities, like you have a metro station which is the below ground. So, in that kind of situation, what you should have to do? See, if you do not put these walls, so these may be different types of retaining wall. The term retaining wall suggests that it will retain the soil in place. Soil means the soil in the back side. So, if this wall is not there, what will happen? The soil from the back side will start caving in the excavation zone. You may think, what is the problem? Okay, it may cave in, then I may remove it after some times, then again continue. No, if the soil surrounding caving in, what about the surrounding structures? They are already existing, right? They are, I mean, it's like you are standing and below your ground is going. So, what will happen to the building? They will definitely will collapse, tilt or damage or crack, and then what will happen? The owner of the building will put a case against this work, isn't it? So, everything will stop. So, these are very critical things. So, geotechnical engineer's job is to ensure two things here. One is you have to have a safe working environment here, so that the people who are working will not get buried by the soil collapse. At the same time, you have to ensure that nearby or adjacent structures should be least or no damage by your excavation, isn't it? So, there are two major responsibilities, and it is a lot of money involved. Secondly, second side is these excavations for the tunnel. You see these tunnels are going through this ground. It can be a rock tunnels, that means tunnel that crosses the hills, or it can be a simple tunnels in the in soil, like in Chennai. Many places we have the metro rails going through the tunnels, and those tunnels are not through the rock, it is just simply in the soil. So, there are certain machines which can dig the tunnel in rock. There are certain machines, it is like your drill machine in a mega scale, which can drill the clay, which can drill the sand, or which can drill the rock. Depending on the soil, you have to choose the machine, because that also important. Selection of the exact tool, otherwise you will be end up nowhere, right? Your work will be delayed. So, based on the soil characteristic, physical behavior or mechanical behavior, you have to choose your type of equipment to be used. Okay? Then the soil can be encountered, those whatever we discuss now is a kind of a standard thing. You can have a foundation, you can have excavation, you can have embankments and all those things. But there are certain cases where you may encounter soil in some very specialized or sudden severe situation. One of them is, let us say, it's some place earthquake happen. What will happen? If there is an earthquake happen, usually there are two phenomena very common. One is called liquefaction, another is called sand boil. So, it is something like this, you shake it, the ground will be shaking, right? Earthquake means ground shaking, right? Ground will be shaking. What will happen? The top soil, if it is certain characteristic, it is not so favorable. What will happen? That top soil will behave like a water. That is what, it is like a liquid. Now, we all know that liquid has shear strength of 0, right? Liquid cannot take any shear, water cannot take any shear. So, that is simply thing it happened. Now, what will happen? The building is standing now like this, very safe, very nice, we are having class here. Then bottom it started shaking. So, the foundation and adjacent the soil, because of that shaking, because of certain property of the soil, become almost liquid. So, what will happen? This guy will fall, that is what happened, this building, you see, this building just tilted back. This happened in Japan in Niigata earthquake, one of the severe earthquake happened and it's collapsed. All the building got tilted because of this. So, it is an instantaneous phenomena. It is not that the soil adjacent to the foundation will be forever like liquid. It is a for an instance, it will just like a liquid, but to kind of tilt a building for an instance of that kind of loss of strength is good enough. So, that is what happened to this structure. Now, even if there is no structure in just regular road, highways or something, there is a chance that with this there may be some kind of fountain type of behavior generates. So, the bottom soil, as the top soil now it is almost liquid, bottom soil will start floating and coming like a boiling type of situation will occur. So, it will happen. These are the things very common happened in Bhuj earthquake in 2001 in Gujarat. These are very common features. Another major catastrophe is the piping. What do you mean by piping? Just now we said the embankments, right? So, this is the embankment and this is the storage reservoir. This is the water stored. It can be for agriculture, can be for drinking, can be for any industrial application, something. It is a big reservoir. But due to certain reason, certain failure, certain lack of monitoring, that is what I say, the monitoring is so important. Lack of monitoring, what will happen is, there will be certain problem in this downstream side. So, this is your upstream side where the water is stored. In downstream side, a situation comes, something that water from this side forms a like pipe below this embankment and it is coming up here. So, this water is basically coming from the reservoir itself. You may say that okay, is a little bit of water coming, what is the problem? It is not that amount matters. First thing is that small amount over the years may cause a substantial loss of water from the reservoir. At the same time, what is doing here is, while going through below the dam, what will happen? The part of the dam material, it will get washed away of the water. So, finally, what will happen is this part of dam will become extremely weak and this zone will become critical. In geotechnical term, we call it, it is a critical hydraulic gradient has been reached. That means, there is a flow occurring and the flow is such that the ground is not able to contain that flow. So, the flow is coming up this water and form an ice stream. So, that is two problem occurs from that. One is you will be losing water from the reservoir, at the same time your dam itself inside it is becoming weak because it is getting washed away every day. Okay? So, this is another challenging situation where geotechnical engineers interventions will be required. Now, finally, there is one more very important thing is called expansive soil. So, there are certain type of soil which has a very bad affinity for water. So, that means in rainy season when ground is completely wet, they will absorb the water. Now, while absorbing the water, what will happen? Their volume will increase, is not it? It is a simple common sense, right? If you have a mass of soil, you pour some water, the volume will increase because they will absorb it. That is fine. Now, next time monsoon is over, now it is a bright sunshine and all those things, dry season, what will happen? They will expel the water very fast. Now, while expelling the water, what will happen? The volume of the water will, volume of the soil will reduce, right? It is a kind of a shrink, it will shrink to a small volume. Now, consider a structure is standing like this, below a soil is doing this kind of thing. It is rainy season, it is absorbing water, increasing the volume, and the dry season it is expelling the water and kind of shrinking. What will happen? This guy, this building below, when volume got increase of the soil, we will have a uplift type of pressure, it is a upward force, and then next time when the after 6 months it is a completely dry season in the summer, it is getting shrinked. What will happen? This guy again will go back to its original situation. So, there are situations where the buildings may not be able to take this expansion and the contraction of the soil, which may end up with getting cracks in the buildings, like typical cracks in the buildings is like this. And more importantly, in India we got major problem in the road sectors. See, buildings still can be manageable, small cracks, it is okay, you the residents will take care. If it is a small crack, immediately they will do something. But kilometers long highways and enter our Telangana or middle plateau, Deccan plateau is full of this type of soil. So, we are getting every time lot of problems of the cracking in the pavement due to the expansive nature of the foundation soil. The soil below, it's same thing happen, right? The soil below pavement will expand and contract regularly. What will happen? There will be a unforeseen stress induced to the bitumen layer, the top layer. So, definitely it will try to open up depending on the extensiveness of this volume change. So, this is called swelling and shrinkage nature of the soil. It's the key word is swelling and shrinkage nature. So, the soil will swell and shrink depending on the amount of water going inside the soil. Okay? And this is very dangerous, particularly for lightly loaded structure. This one is from Chennai. You see, this is called subsidence or collapse. This happened in 2017, I believe, it is taken from the newspaper itself. You see that this is the one of the major road in Chennai, where the below the metro rail works was going on, and what will happen due to certain activities or metro tunnel drilling, there is a certain subsidence of the road happened, and then this car and the bus got all caved in. So these are the situation also geotechnical engineers will be called, and they have to run around and see what are the reason behind that, what should be the precautionary, because the issue about the geotechnical engineering is you cannot simply say no, we shouldn't do the tunnel. Tunnels to be done, right, because you have to run the metro, but at the same time you will not be able to say that okay, let the bus collapse, no, right. So you have to manage both sides. So you have to design your tunneling methodology in a way that it will have a minimal disturbance to the road in top. So this is the real challenge, because soil every part will be different along the long stretch of the road. So you have to have a proper identification of the soil, what type of soil now you are digging, what kind of precaution now you are taking. So again, continuous monitoring will be the important, the key issue here. So all around we should have a continuous monitoring to see is there a gradual, because this may seems gradual, sudden, but this kind of thing will happen in gradually. It is not just that one day it collapse like that. Over the years there will be a settlement going on, over the months at least. So you have to have a telltale sign that okay, see there is a settlement is going on, it may be excessive. So you do some necessary precautionary measure. That is what the geotechnical engineer's job also. So now foundation, let's, because you see of all said done, you will be 50% of the geotechnical engineer's job will be related to something to the foundation. So let us look at in a bit detail in the foundation part. So we have to decide what type of foundation, what is the depth, what is the size, what would it require support during excavation. That means while you are constructing the foundation, whether you need the surrounding support the soil. So that again safety of your people who are working there, at the same time safety of the adjacent structure to ensure. Would it necessary to lower the groundwater table? That means groundwater table, let us say in all the coastal cities, groundwater table is almost at the surface level, right. And what will happen? If you dig up a soil, water will start flowing in. If water flows in means it is not only inconvenience to the people who are working, at the same time you will have the machineries, electrical lines which will be getting affected. So you need to lower the groundwater table in the vicinity of the work site, and then you do the work. After that you recharge it. After the work is over, you just let the groundwater table come back to its original level. So whether it is necessary to do that, is there a danger of damage to the adjacent buildings? With all this, all the work activities, are you disturbing the nearby structure or the resident? You may have a pile like you have seen in the foundation pile. So when pile is getting installed, there is a method you have to drive it. So there may be a noise coming to the building. So nearby residents may complain that it is like a hammering sound, it is a day and night there will be hammer. So these are the practical challenges what geotechnical engineer also has to face. So this is a building, see it is almost 3.6 meter settled. So the road is something here, the road is actually here, the road level. Now the building level went down like this. So almost 3 meter, it is almost one floor, more than a floor. It's got the floor supposed to be, the bottom of the building supposed to be at this level, but it went down inside. Because of the, that's what I said, the foundation is not capable enough to take the settlement. Now the problem here is, why I am showing this thing is, there are settlements which may not be that bad in looking. That means entire building is settling in same level. What will happen? Maximum thing is your ground floor height will be reduced, or most of the time now we have the ground floors are car parks. So your car park's depth is little bit of reduced, but as such structurally there will be no damage to the building, because everything settled uniformly. Instead of some level, it is just went down to say 100 mm. Now uniform settlement will not be a problem structurally, but the problem is there a pipeline going down below? So let us say there is a sewerage pipeline or water supply pipeline. The building settle 100 mm means all the pipe will get broken, right? Connections cannot take, particularly if it is a concrete pipe or something, the connections will not be able to take that kind of pulling or pushing effect, isn't it? So, it is not just the structurally, you have to think the utility point of view also. Are you touching something to the optical fiber lines going below the building? Are we doing any harm to the electrical lines or sockets? Are you doing anything to your safety tank or reservoirs, water reservoirs within the building, within your property? So, all this thing comes into the picture. So, it is not just a settlement, it is like settlement will cause not only the main building, it can cause the problem to the associated structures or utility lines as well. So, that is what the problem. Now, if it is does not settle uniformly, then that is even more problem. So, that means one part is not settling, other part is settling. What will happen? The thing may tilt, it may break the beams and columns, because beams and columns will not be able to take that additional disturbances of the moments coming. So, how we analyze the stresses below a foundation? So, stresses below, let us say this is our foundation, stresses below foundation is like the building load is coming on top, it will be distributed over certain zone. Let us say I have a 100-meter depth of soil and you have a foundation like this. Do you think that 100 meter below this building will be stressed? No, right? There are after certain time, after certain depth, there may not be any load coming from the building. So, what is the zone below the foundation which will be active? That means which will be stressed. Obviously, at the below here, it will be maximum stressed. As you go down further deep, your intensity of the stress is getting reduced, and beyond certain depth, it can be negligible. So, that is where it is called pressure valve below the foundation. So, it is a very important term, it is called pressure valve. So, pressure valve below the foundation is a zone where due to the foundation load, the stress will be of significant in nature. So, whatever the settlement occurs and other thing will be the settlement or compressibility nature of the soil within this pressure valve. So, the soil within this pressure valve will compress, will get reduced in thickness. So, solution to the soil engineering problem, you need to have a soil mechanics, engineering, geology, economics, engineering judgment. You have seen in the earlier classes also. The term soil mechanics was coined by a Professor Karl Terzaghi in 1925 in his book written in German. He is considered the father of geotechnical engineering, Karl Terzaghi. Soil mechanics, he says, according to him, soil mechanics is the application of the laws of mechanics and hydraulics to engineering problems, dealing with sediments and other unconsolidated accumulation of solid particles produced by mechanical and chemical disintegration of the rocks. It is very important. The soil mechanics term he is first used in technically. So, soil mechanics is the one that deals with the sediments which is kind of formed by the weathering action of the rock. So, soil mechanics is therefore a branch of mechanics which deals with the action of forces on soils. The importantly is the flow of water, because below you there is a water and soil mix up, isn't it? There is a groundwater table also there. So, that is where the problem comes, because here you see solid mechanics and soil mechanics is slightly different. Solid mechanics, you are talking about the fully solid material, but in soil mechanics or geotechnical engineering, you are dealing with a material which is having solid, which is having liquid, at the same time which is having void space also, which is neither solid nor liquid. It is like some kind of air infilled. So, always in soil mechanics or in a foundation engineer or civil geotechnical engineer deals with a situation where three different phases always present: solid, liquid and the gaseous phase. Any type you take a sample of the soil, you will have the water, you will have the soil particles, that means solid phase, you will have the gaseous phase. So, that is the big challenge. That is why some people want to call it as a particulate mechanics. Now, Karl Terzaghi has famously commented this in 1951, that on account of the fact that no glory attached to the foundations, that the sources of success or failures are hidden deep in the ground, building foundations have always been treated as stepchildren, and their acts of revenge for the lack of attention can be very, very embarrassing. So, this is a classic comment Terzaghi make, that most of the time foundation engineers, civil engineers ignore the foundation. Like I said, that after some years we do not care about the laptops and other thing. Same thing, we think that it is there and it is not visible in the naked eye. So, that is why we kind of forget that there is a material there which is actually taking the load. Whatever beautiful structure you constructed, ultimately load will be going to the foundation, to the below. Unless we take care properly in the foundation, it can be catastrophic in nature. So, brief history of soil engineering we have used for many structures. Historically, you have India, we have a Taj Mahal, pyramids, Great Wall of China in China, all kind of marvels, but everything stands. There is a serious involvement of geotechnical engineers are there. So, who are the pioneers in the field? This is the famous person, Leonardo da Vinci, although he is known for his some other works, but he is the one that first started analyzing the soil in mechanics way. So, he coined a term called angle of repose of sand. That means without support, what is the angle through which we will stack the sand? What should be the optimum angle beyond which the sand will start rolling off? So, he started a test method to understand the bearing capacity. Bearing capacity means, just now I said, how much a soil can bear the load. So, that capacity, how much is the resistance they can provide to the building. So, he started all this thing in a very interesting way. Next one is the famous person, another famous, Coulomb. He considered is the first use of, in fact, he first designed some kind of geotechnical structures in terms of the embankments for the counter fort walls to fortify the certain forts in Caribbean. And he is the one first introduced the term friction, and that changed the geotechnical engineering completely. He is the first to use the term friction, that the soil, that strength of the soil is coming from predominantly from the frictional nature of the particles. So, finally, this is Felenius. He is a more recent person. I mean, I would say that he is the one of the pioneer figure in our recent times. He is born and educated in Scandinavian country, Sweden, which is having traditionally very poor soil condition, where the soils are extremely weak in nature. So, we had to invent various methods to treat that, to construct buildings, construct harbor and the port structures for this kind of thing. He is the one first created a soil mechanics laboratory. In history, he is the pioneer on the creation of a laboratory for soil mechanics. Finally, the Carl Terzaghi, he is the father of soil mechanics. He is born in Prague. He is actually, interestingly, he is a mechanical engineer. He understood that solid mechanics, and then from that he extended his knowledge of solid mechanics to soil mechanics. So, he kind of include the effect of gaseous phase and the liquid phase in the solid mechanics. All our major theories are developed by Carl Terzaghi. So, he wrote this book, and it is kind of still in practice. We are still using this. Carl Terzaghi and his students, Ralof Peck, their book is the first book in soil mechanics. So, he felt why he, as a mechanical engineer, why he was interesting. It's a very very enlightened story, because he was doing something on the dam constructions in Europe, and he understood that there are so many empirical equations the engineers are using, but without knowing the soil. So, they may be using an empirical equation which can be valid for the rock, but they are implying it for the soil, or vice versa. Even within soil, something can be for the granular soil, something can be finer soil, but we are not knowing where we are kind of applying those empirical equations. So, from that he started understanding the soil. He created his own small lab, and he started testing different materials, and from that he developed two major principles. One is called effective stress principle, another one is called consolidation theories. These two is the kind of pillar of soil mechanics, these two theories. All our soil mechanics theories are actually stands on effective stress principle and consolidation theory. So, he was later become a faculty in Harvard University and MIT, and he is kind of considered started the journey of soil mechanics and foundation engineering as such. Okay? Thank you.